Okay, another week. Thanks everyone for putting in all of your questions on the question show. As always, wherever you are on the channel, if you got some question about space and astronomy, go ahead and type it in and I will gather them up. Before we get to it, a couple of points of order. First, did you get a chance to see the lunar eclipse? I did. It was perfect. The lunar eclipse went right past my bedroom, and so I was able to lay in bed and watch the entire eclipse from sort of the beginning to the end and not even leave the covers. It was absolutely perfect. So I highly recommend that. Very, very civilized. The second thing is a huge thank you to all of the patrons who have been supporting us. Just wanted to sort of show you, right, that we have been putting a lot of that, all that donations back into the quality and the production levels that we're doing. We've got a better camera. We've been able to purchase stock music, stock footage and photography, be able to include that. Chad has edited 260 episodes. We were just talking about that today, and the episodes are so much longer. If you go back to the beginning, it was like me in front of the camera with like 6 photographs up to the side for 3 minutes, and now they're 10 to 15 minutes long and almost all 4K graphics. So thank you everybody. And if you want to join the Patreon, go to patreon.com/universetoday. The second thing is I'm off to Iceland in about, I guess, 2 days, 3 days after you see this. Of course, this is where I'm going with Dr. Paul Sutter. We're going to be going to Iceland and chasing auroras with 30 of our closest friends. We announced this a year ago and now it's finally happening. But the other trip that's coming up is the one where we're going to be going to the Eastern Caribbean on a cruise. And we're going to start at Cape Canaveral, and then we're going to head around in the Caribbean, and we're going to set up telescopes every night, and we're going to do live versions of our shows and teach you about space and astronomy and just kind of hang out. So if you already have, if you haven't got vacation plans and that's something that you want to do, go to astrotours.co and you'll see a link to the Sea and the Stars cruise that we're going to do. All right, let's get on to the questions. Larry Johnson, thanks for the videos. While I've been to a couple of dark sky sites in the US, I can see the Milky Way after a while, after my eyes acclimate to the darkness. Have you ever been to the southern hemisphere in a dark sky site? And if so, does the view of the Milky Way improve? Thanks again. I have never been to a dark sky site in the southern hemisphere. I have never been to the southern hemisphere. The closest that I've been to is like Costa Rica, which is pretty far south, and I got to see some new constellations, but I've never been to the southern hemisphere. But that's going to change. I'm going to be in Australia in July 7th and 8th. There's a festival, an astronomy festival called Star Stuff. It's going to be in Byron Bay. I'm going to be there with Amy Shira-Tidal and a bunch of other people. So that's going to be my chance with a bunch of great telescopes to actually get a chance to see the southern hemisphere and I want to see the large and small Magellanic Clouds. I want to see the Omega Cluster. I want to see Alpha Centauri. I want to see Eta Carina, which is going to be this star that's going to explode, in probably the next one that's going to explode as a supernova. The Doradus constellation, the Southern Cross. There's so many cool constellations and objects in the southern hemisphere. I'm kind of jealous that I've never get a chance to see that. So that's coming up in July, which is another trip I'm going to be doing. I think there might still be some spots available at the Star Stuff event. I'm not sure, but do a search for Star Stuff 2018 and I'm sure you'll be able to find it. Ken Lepre. Hey Fraser, as we look further back in time, we see galaxies and now even a black hole that formed only a few 100 million years after the Big Bang. With the next generation of telescopes coming on board, what are the chances that we'll find some structure that is so young it challenges the Big Bang theory? Right. Right now, the limits of what we can see sort of depends on the observatories, right? There is what we can see in the radio spectrum and the microwaves, and that's what, with these all-sky surveys like the cosmic microwave, of the cosmic microwave background radiation, like the WMAP probe, and the sort of the next level, the Planck satellite, and these are mapping out the microwave, the afterglow of the Big Bang, and these can see pretty much right out to the edge of the observable universe, to the point that the universe had cooled down and light could escape. But in the other wavelengths, like invisible light and so on, our view is not so good. And this is one of the things that, say, the James Webb Space Telescope is going to be able to do. It's going to be launching, it's going to have the power, it's got 100 times more power than the Hubble Space Telescope. That's a very rough estimate, and I know a lot of people are you know, it's not apples to oranges. James Webb is an infrared telescope, so it's going to see much longer wavelengths than the Hubble Space Telescope will, but due to the expansion of the universe, what used to be visible light and ultraviolet light has been redshifted, has been stretched out to this infrared spectrum. And so James Webb is going to be able to peer out to the edge of the observable universe and be able to see objects very shortly after the Big Bang. And right now, the only way that astronomers are really able to do this is by these kind of bank shots. They're able to use gravitational lensing to be able to see a distant galaxy that's being lensed by some closer galaxy, and to be able to observe this much farther galaxy. James Webb is going to be able to brute force these things. Will they discover things that will overturn the Big Bang? I don't think so. The Big Bang has done a really good job of being able to explain the expansion of the universe as we got to this point. But the part where the Big Bang is still, people are still really uncertain, is about like what happened right at the very beginning. What were the first moments after the Big Bang in the inflationary period, as sort of these initial epochs were getting set down before we got the 300,000 years to the point that we got the cosmic microwave background radiation. And so not just in, say, infrared, but like the next wave of gravitational wave astronomy could be able to peer beyond the cosmic microwave background and be able to see the ripples of gravity and space-time before the light was able to escape, and give us a better understanding of what the structures were. So there's still a tremendous amount of work to be done, pushing further and further beyond, right to the very edge of what is possible to observe. So I don't necessarily see anything that's going to overturn the Big Bang, but I do see that astronomers are going to understand they're going to fill in all these little pieces that are still big mysteries. Margot Robinson. Why does stuff in the universe spin? What kicked the spinning off initially, and what keeps it going? When you think about a thing that's spinning, think about all of the objects in the solar system, right? If you run the clock backwards to the very beginning of when the solar system came together, it was this big cloud of cold hydrogen. And then some event like a supernova shockwave or something kicked off and set this big cloud starting to come together. And if you could look at every single individual hydrogen particle, you would see that it's got its own velocity, it's got its own direction that it's moving through this gigantic cloud. It's essentially its own orbit, but then they're bumping into each other and they're starting to clump up. And as they clump up, they start to average out the velocities that each one of these particles is having. And so when you really look at, say, the way that the solar system overall is spinning, the way that the sun is spinning, that is the average out of all of the particles that were in that initial solar nebula back in the beginning. And now they've all averaged out and they've all come together, and now the whole thing is just spinning with this average. And it's the same thing with the Earth. It's the same thing with every other galaxy that's out there, every other planetary system that's out there, everything that is spinning. Now you've probably so it's the average of all this momentum, but then the other part to it, of course, is the fact that, you know, as an object pulls together and it averages out that momentum, the closer it pulls together, the faster it spins. And the classic analogy is an ice skater who is pulling in their arms or legs as they're turning, and they spin up faster. And so you can imagine what started out as this big cloud of hydrogen, as it starts to collapse more and more, starts to spin up and get faster and faster, and it is the average momentum of all the individual particles, which is a really cool idea when you like to think about that. Danish Gagai. Do you think we'd be able to build a telescope powerful enough to see Earth-like planets around different stars? And would such a revelation make the Breakthrough Starshot initiative of no use? We're a long, long way from being able to directly observe Earth-sized worlds orbiting other stars. Right now, the best that we can do is detect the presence of Earth-sized worlds orbiting red dwarf stars, stars which are a lot smaller than the sun, and so as the planet moves in front of the star, it blocks out some of the sunlight, and because the stars are smaller and cooler, then these worlds can be detected. The next round is going to be things like TESS and some of the Earth-based planetary finding observatories and missions, is they're going to be able to crank up the sensitivity and be able to see these Earth-sized worlds orbiting sun-like stars. But it's still going to be this kind of indirect observation. You know that it's there either by how the light from the star moves back and forth because the planet is yanking on it with its gravity, or how the light dims as the planet moves in front. But there are some amazing images now from some really powerful telescopes that are starting to directly observe planets. Now you're looking at gas giants, but you can imagine this technology moving forward, and maybe in the next couple of decades when the next generation of really powerful telescopes like James Webb, or what's going to come after James Webb, they're going to be able to directly observe. And so I think we could gather tons and tons of data about these other worlds, but I can't imagine a time when we would not want to be able to go and take a look at them close up with something like the Breakthrough Starshot, some kind of interstellar spacecraft. We can see Mars with the Hubble Space Telescope, we can see Jupiter, but we still want to get close up and land on the surface of some of these worlds and observe them directly. So I can imagine sort of that next generation of telescopes just whetting our appetite. We're going to see these worlds and want to know more, and build bigger telescopes and want to know more, and eventually send spacecraft and want to know more. So that's how this works. Michael Kalowski. Did you ever consider a career in space, not as an astronaut, scientist, or engineer, then as a manager of a sort, or a logistics guy? I'd love to work in the industry, but my education and professional experience are not very space related. I did want to work in the space industry briefly. When I left high school, I went to university and went into engineering, and my plan was to go into mechanical engineering and then try to move that into aerospace engineering. And part of the problem was I realized that going into mechanical engineering actually means you work on heat and air conditioning systems for buildings most of the time, and I'm sure the professional mechanical engineers are nodding at this, but I also just kind of fell in love with computers, and so the direction of my career moved into computers, and now my degree is in computer science. But absolutely, I wanted to be involved in it, and this was the pathway that I took to get involved in it. And I'm really glad that I did, that I much more enjoy being able to kind of be a part and help promote and help communicate the science behind lots of different missions than any one. If you want to get into the space industry, my advice is computers, as always, right? Engineering and computers, especially computers, because a lot of astronomy and a lot of what the people who work with the spacecraft do is they work on computers in programming to communicate with them, helping to analyze the data that's coming back. So if you want to get involved, now if you haven't already done that, it's never too late. You can always go back and learn computers and start to work on some projects on the side. There's a ton of citizen science projects and amateur projects. The costs of spaceflight are coming down so fast that in the next few years, you're going to see people being able to launch their own satellites for a fraction of the price of what it used to be decades ago. So it is never too late. Never say that you missed the chance to be able to do this. Dig in, find some projects, participate, help out, and you will find yourself working your way into more and more interesting projects and being a part of really amazing things. So do it. The sweet words. Humanity Star. Has anyone sighted it already? So for those of you who don't know, there was the Electron rocket that launched a couple of weeks ago, and they did a bunch of payloads, and one of them is called the Humanity Star, and it's this like 20-sided die metallic sphere that's floating around the Earth, and it's going to be up there for about 9 months, and then it's going to re-enter the Earth's atmosphere. And you can do a search for Humanity Sphere and find its current location, and then be able to find out when it's going to cross your area, and then you can go outside, and you should be able to see, and it should be very bright. I haven't seen it. I did a search on their website, and I won't see it for another couple of thousand hours at the least. So I don't know when it's going to happen. I'd love to hear if you've seen it. Now, I know there's a big controversy about this thing. A lot of astronomers are pretty grumpy that someone is putting additional light pollution up into the sky where it's going to pass right through their field of view, and I totally get that. It is like, I think it's fine to do this one time, but don't do this a lot, because the darkness of the night sky is really precious, and it's fun as a stunt once to kind of bring people together and have them to go outside and look up and see this really cool bright star go by and take a picture. But for poor astronomers who are trying to take a field of view and the super bright star goes through and wrecks a chunk of their observing data would be pretty frustrating. So, but let me know if you've seen it. I haven't seen it yet. I check out the website every now and then, and I haven't seen it. Varshavga Vigya. I bought a new telescope. What should I look at? Congratulations. You didn't say what kind of telescope it is, but for anyone who gets a first telescope, there really aren't a lot of objects that you can, the obvious ones are the moon, some of the bright planets. Right now, at the time that I'm doing this, Jupiter and Mars are up in the morning, and Mars is going to be terrific this year. It's going to get very, very bright. It's going to be almost as bright as we saw Mars back in 2003 when there was that big hoax that Mars was going to be as big as the moon. It's not going to be as big as the moon, but it's going to be very bright and you're going to be able to see it. And depending on the power of your telescope, you might be able to see the polar caps on there. You should be able to see the bands across the planet Jupiter, the moons. Saturn is up, I think, and you should be able to see the rings of Saturn. You're going to see some really great detail on the moon. To go to the next level, then you're looking at some of the more fainter objects, some of the deep sky objects. My favorites are the globular clusters. Go and find, depending on where you're at and what hemisphere and sort of what time of the year, there should be various clusters that you can see, and they're really cool because they look like this little fuzzy ball of stars. They totally look like this miniature version, and I really enjoy those. Some of the planetary nebulae are really great. The galaxies are kind of tough, but you can find them and sort of check them off your list. To take this to the next level, you're going to want to get some kind of camera attached to your telescope and start taking some pictures. And that's when you start to leave your telescope running for a long time and get some really nice, longer exposure photographs. But congratulations, and congratulations to everyone who got a telescope over Christmas, and I hope you put it to use. And again, in the comments, let me know what you looked at. Master G. Moore, how do you feel about life in the ocean on Earth, an area less understood than space? I took an oceanography class in high school. Water is essential to terraform. How can studying our oceans help us understand terraforming? Yeah, it's strange that, people say this, we've better explored space and the solar system and the surface of Mars and things like that than we've explored the oceans here on Earth. And it's an enormous field of scientific study, and one that is crucial to life on Earth, to the way the atmosphere connects with the ocean, connects with the life, with our food chain, and then when you think about the kinds of ways that we're polluting the oceans with all of the plastics and things like that, it's a tremendously useful thing to understand. And then when you think about the discoveries of these hydrothermal vents down at the bottom of the oceans, where you've got these black smokers and you've got these life forms that are existing in an environment that's completely separate from the environment that we have on Earth, this set the stage for our understanding of these other environments, places like Europa and Enceladus, where you could have the same situation with bacteria living under the water, and they could be fed by this hydrogen, and you could have this whole ecosystem that's down there. And that was like a direct result of work that was done to understand the oceans here on Earth, to work that's done to understand some of the other places. I'm not sure about terraforming, but obviously the better we understand the role of an ocean and it's how it needs to be part of the overall environment, the more prepared we are when we try to create the same thing on another world like Mars. Ian Stradian, why don't we send a fuel cell into orbit, then send up a spacecraft to supply and cargo unit, allowing for a larger vessel and fuel to push it to greater speeds? It always seems to be that it's a mission they do in all one load. This is a constant debate between people who are planning space missions. Like, on the one hand, you've got the people who say, let's launch smaller rockets, put things into orbit, let's put them together bit by bit, and then when you've got your fairy spacecraft that's going to take you to Mars, then away you go. And this has been proposed many times. And then there's this other view, which is, let's just get the biggest rocket that we can, let's pile as much stuff into that rocket as we can and just do the whole thing in one big mission. And there are good and bad reasons for both of these. When you think about what it took to build the International Space Station, you had dozens of launches with many different parts, and then you've got all of the various Soyuz craft that are docking with it and helping to boost it. It was a very complicated undertaking. It's a very complex structure, very big and very expensive to build, right? Billions and billions and billions of dollars. The other alternative is when you think about things like what the Space Launch System is going to be able to do. There is the Bigelow 2000, I think. It's going to have an enormous inflatable space station. It would launch in one go. You would just take the whole thing, it would be sitting on top of the rocket, the thing would launch to space, it would expand, and you would have a space station with as much internal living area as the whole International Space Station in one go. I know that for missions to Mars, Bob Zubrin likes the Mars Direct approach, which is one big rocket that goes to Mars and drops the landing craft down onto the surface of the planet, and people start to build fuel and stuff to return home. So you're always going to get this back and forth, and it really all just depends on exactly what the mission is going to be, what the constraints are that you have to deal with, the rockets you have available to you, the capability of the engineering team. There's just so many factors, but you will always, every time engineers are thinking about these problems, they'll just go back and forth. Should we make one? Should we try to launch it? In general, it seems to be more often that they do go for these one big launches, except we've seen things like the International Space Station, which is a whole bunch of stuff built together. So it's an ongoing debate. Chris Sham. Surely it's got to be possible to borrow a small camera from a phone and dangle it loosely outside the spacecraft on a long, thin cable to feed the pictures to the spacecraft's memory transmitter. That should still be a few grams and barely any money. Letting it swing freely means it'll naturally capture several different angles, and if 99% of them are crap, at least we'll get the 1% of good ones up from the 0% currently, though I'm confident someone could design it way better than only 1% successful. So this is back to the, why don't spacecraft have selfie sticks? And so I guess Chris is saying, like, what, and I had a bunch of people sort of propose the same idea, which is like, why don't we just take like a small phone and have it connected to the spacecraft, and then it can take, so then the spacecraft can truly take these selfies of itself in front of Saturn and in front of Jupiter and all these places. And the point is, like, why, right? Like, why would you want the picture from the selfie when you could get the picture from the enormous, very carefully built, telescopic lensed, multi-CCDs was filtered main camera that is on the spacecraft? When you think about the one that is on Cassini, or the one that's on the Mars Reconnaissance Orbiter, that is like this gigantic telescope that is orbiting Mars and viewing the ground, if the only point is to prove the existence of the spacecraft, why? Like, and this was back to what I said in the episode, which is like, the people who create these spacecraft don't have anything to prove. They want to bring the science in from the spacecraft. Now, I think there is value when we look at what happened with the Juno spacecraft. It has, it had a camera attached to it kind of at the last minute, and it's not like a really high-end science instrument like what you see on some of the other spacecraft. And a lot of it was just to give the public a view. And so I think if you're going to build a spacecraft and you're not planning to put a camera of any type on it, I think that's a big mistake. You need to have a camera on your spacecraft, at the very least, to give the public access to the pictures so that they can enjoy and be able to talk about and share and help promote what's happening on the camera. And I think it also makes sense to have multiple cameras, like what they had on Rosetta. There was the sort of the main camera that Rosetta was using, but there were also these navigation cameras and stuff that they were putting out to the public on a regular basis. And I thought that was a great idea. But a camera that's only job is to prove the existence of the spacecraft? No, I don't really see the point of that. Jerry Watson. I don't understand. Why would a group of beings want robots to replicate themselves and then go to another world and do the same thing? Am I missing the point? Who cares if robots go to other planets unless they're just checking things out before we go? Well, I think you got right to the point, right? Which is that they're going to check things out before we go. That that as we, and this is this idea of these von Neumann probes, these self-replicating robot probes that would be moving from star to star, exploring the entire Milky Way. They would land on one world, they would build copies of themselves, they'd go to another world, and I can imagine a bunch of reasons why an alien civilization would want to build these kinds of robots. And the first one is literally just to scout out the galaxy, to send enough spacecraft out to then send all the data back and go, okay, now we understand. These are all the stars that are in the Milky Way. These are all the planets that orbit all the stars in the Milky Way. These are all the life forms, all the alien civilizations that are out there across the Milky Way, to understand as much of the Milky Way as they can. And once you get these spacecraft going and they're building more copies of themselves, you just kick back and wait for the data to roll in, because they're doing the hard work. But then you can imagine sort of more sinister reasons why aliens might send these spacecraft out, like they want to chart all of their potential enemies, all of the future threats, so that they might want to find other civilizations and then send invasion fleets to get rid of them before they become a problem down the road. And this is this idea of the berserkers. So I can imagine a lot of reasons why aliens would want to send self-replicating robot probes to other stars. At the very least, just for science and understanding and to make new friends, and at the very worst, to find and understand and make new enemies. And I can see why they would want to do that. All right, that's it. Thanks as always to everyone who asked all of the questions. As you know, wherever you are on my channel, if a question pops into your brain, just type it out and I will answer them here. We'll see you next week.